We're continuing with Math 125 Gateway questions, this time number 86 out of the series 81 to 90. This question is f of s equal to numerator tangent of 2s, denominator cosine of 1 minus 2s. And I would like to present two methods for solving this question. The first one, I'm going to change the denominator and bring it to the numerator with a negative power. So the first method I'm using, I'm bringing the entire denominator to top to power -1. This makes it a chain rule. And this is my recommended method of solving this problem. So this makes it a product rule, and is my recommended method of solving this problem. How is it a product rule? There are two factors multiplied together, so the connection is a product. When I'm taking the derivative of that, I have to do derivative with respect to s of f of s is going to be the derivative of the first one times the second one, unchanged, plus the first one, unchanged, times the derivative of the second one. Okay. The next step is to find the derivative of each factor. Derivative of tangent of 2s, this is going to be a chain rule. Outside function is tangent, inside function is 2s. Derivative of tangent, we have it over here, is the secant squared. So this entire thing becomes secant squared of inside untouched, unchanged, times the derivative of inside. Derivative of 2s is going to be 2. The other derivative of the other factor, I have two chain rule to take care of for that one. One is very outside function, that is to power -1. So let's do that one first. Very outside function, -1. The entire inside function to power 1 less, which is -1 minus 1. And I put the entire inside function in there. Then I have to take the derivative of the inside function. Now, derivative of inside function is also a chain rule. The outside function in here is cosine of cosine. Inside function is 1 minus 2s. So now, if I'm replacing this by its derivative, what I get is derivative of cosine, which is negative sine, inside unchanged, times the derivative of inside, which is derivative of 1 is 0, derivative of negative 2s is -2. Now let's write this all down by replacing all the calculated derivatives. So the first one, the derivative of the first factor, times 2 times cosine 1 minus 2s. The entire thing to power -1 plus the first term, first product factor, times the derivative of the second factor. which is very outside function. Then times the derivative of inside. And this entire thing is the final answer that you can enter in your gateway exam, and no need to simplify. Next, I would like to give an alternative method. So we're going to use the quotient rule. Take the derivative this time. Derivative with respect to s of f of s equal to big quotient line, denominator unchanged, to power 2, and then denominator times the derivative of the numerator big minus sign, numerator times the derivative of the denominator. Next step is to replace or compute wherever you see the derivative of the either numerator or denominator. Derivative with respect to s of tangent of 2s. This is a chain rule. Outside function tangent, inside function 2s. Derivative of tangent, according to the formula, is secant squared. So it comes out as secant squared of whatever you have inside, which is 2s, times derivative of 2s, which is 2. Over here, derivative of cosine 1 minus 2s, derivative of outside function cosine, inside function 1 minus 2s, derivative of cosine is negative sine of x, replace that, negative sine of inside unchanged, then multiply by derivative of inside, derivative of 1, 0, this is the inside, derivative of negative 2s is negative 2. Rewrite this entire thing, replacing all the values that are in there. With this one is going to be cosine 1 minus 2s times secant squared 2s times 2, negative, and the order of negative matters, then tangent 2s times negative sine of 1 minus 2s times negative 2 divided by the denominator unchanged to power 2. Again, where we started was denominator times the derivative of the numerator minus numerator times the derivative of denominator. That order matters. This is your final answer. Either method is okay to do. You can enter this in your gateway exam. No simplification is needed.